My name is Jeff Procyse. Obviously, I am your presenter for the next hour and 15 minutes. And to make sure you're in the right place, the title of this session is HTML5 Quick Start. And I would like to kick this off by saying that, number one, I'm going to be showing you lots and lots of code samples here. If you would like a copy of those code samples for yourself, one of the slides near the end has a URL that you can go to download all of the samples that I'm going to show you, in fact, even more than I'm going to show you. The second thing I want to mention before we get started is what the goal is right here. Obviously, we can't cover every part of HTML5 in an hour and 15 minutes. So my goal is to show you as much of it as I can, to show you the parts that matter the most, and to leave you with some code samples that you can use to get started using these things as well. Now, my, isn't it an interesting world that we live in today? You know, when I was at this conference a year ago, I was talking almost exclusively about Silverlight. And if you had told me that a year from now, I wouldn't even be working with Silverlight anymore, I probably would have told you were crazy. Isn't it interesting how things have changed? The world is going crazy about HTML5, not because you can do more with it than you can with browser plugins like Flash and Silverlight, but for other reasons. One of the reasons that we like HTML5 is that if we want to write rich browser-based applications and do it without browser plugins, this is the best game in town. Another reason is if you're interested in doing cross-platform mobile development, HTML5 is one part of that story, and in fact, I'm doing a talk on cross-platform mobile development tomorrow. Interestingly enough, if you're following what's going on with Windows 8, when you build a Metro application, as you may know, you have a choice of ways to go about it. If you're an old Silverlight guy like me, and you're very comfortable with XAML and C#, you might choose to build that Metro app using XAML and C#. But if you come from the other half of the world, if you're more comfortable with HTML5 and JavaScript, you can build Metro applications that way too. So for the first time in history, HTML and JavaScript are first-class citizens in the Windows environment. And hopefully, folks who never really thought about writing a Windows app before are going to feel very, very compelled to do that. So we're going to talk about HTML5 here. Again, I'm going to fit in as many features as I can in the time we have together. Lots and lots of demos. First thing you should understand about HTML5 is what it is. HTML5 is not one specification. It's a family of specifications. Many of them technically aren't even part of HTML5. In fact, today, when any new specification comes out from the W3C that has something to do with HTML, we sort of lump it into that HTML5 category. So HTML5 is a loosely defined group of specifications that come together to form a platform for building rich browser-based applications. Now, I've shown the most notable features right here in this chart, and you'll notice that I've color-coded these things a bit. Let me tell you what I've done there. On the left in the blue, you see the features of HTML5 that are widely supported, in fact, almost universally supported today. Whether you're using IE9, recent versions of Chrome, Firefox, or whatever, those features are there, they're ready to use, they're already being used in a lot of real apps out there. In the middle, in the green blocks, you see features that are almost ready to use. In fact, a lot of folks are using them right now. Those features in the middle, you should realize, are not supported by IE9. So if you're going to use those features in IE9, you're going to need polyfills or something to make up for the difference. You'll be glad to know that most or all of those features will be present in IE10. On the far right, in the pink-colored blocks, you see the latest and greatest additions to the HTML5 family. Those aren't quite ready for prime time. Many of them, no browsers implement them yet. But if you check back in 6 months, a year, 2 years, I think you'll find a lot of browsers implementing them. One thing that you can see when you look at those blocks is that in the future, a lot of the work, the development work going on in HTML5 has to do with mobile development. Today, for example, there's no way an HTML5 app without assistance from a framework like PhoneGap can get battery status information if it's running on a tablet, a phone, or some other mobile device. In the future, that will change because there will be a battery status API built right into HTML5. So from left to right, you see features in order of importance and in order of how well supported they are in browsers today. Now, there are some changes to the markup in HTML5, but I'm not going to cover them because that's not why most people are interested in HTML5. The changes to the markup are rather interesting. There are a lot of new elements called semantic markup elements. There are about 20 of them in all. If you've ever read a blog entry, an article about semantic markup, you know that instead of using divs, we now use structured elements like header and footer and article and content and things like that. And that's all fine and good. But if it were just markup, no one would care that much about HTML5. What's really important about HTML5, and the reason many of you are probably sitting here today, is all of the JavaScript APIs that it adds to the platform. The Canvas API, for example, which allows us to draw directly into a browser window from JavaScript. The Web Storage API, which allows us to persist data on the client side without resorting to cookies and other things like that. It's those features we're going to cover. And one of the things that you'll have to grapple with today as an HTML5 dev is not every browser implements every one of these features. So you're going to need to know how to detect those features at runtime so that you can at least warn the user if the browser they're running in doesn't support one or more features of the app that you've deployed. There are two basic ways to go about doing that feature detection. One way is to do it manually, as I'm doing right here. In one example here, I'm showing how to check in JavaScript to see if your browser supports the Canvas API. And the second, we're asking the browser if it supports the Web Storage API, specifically the local storage part of that. But although this works, this isn't the way most devs are doing it today. If you haven't heard of it before, let me introduce you to a library named Modernizer. It's a free, open source JavaScript library. It's becoming popular like jQuery is today. You can do a search and you can find the download URL. Modernizer does two things for you, folks. Number one, if you're using the new semantic markup elements in HTML5, and there's a possibility your customers will be running these pages in older browsers, those pages with the semantic markup elements are probably going to look really, really crummy in the older browsers like IE7 and IE8. Just by including Modernizer in your app, literally inserting a script element that points to modernizer.js, Modernizer fixes that so the new semantic markup renders properly in older browsers. That's one thing that Modernizer does. There's something else that it does. It has a very simple to use and to understand API for detecting features of HTML5 and CSS3. These two examples you see right here are the Modernizer equivalents of the two examples you saw on the previous slide. Modernizer makes it easier. Doing it without Modernizer means learning about a lot of little tricks and quirks of JavaScript and the browsers to do proper feature detection. Modernizer builds all those tricks in under the hood. It's one reason it's so incredibly popular. And I am going to skip this demo right here just so we have plenty of time for everything else since we got started late just a few moments. What I normally do here is bring up in 4 or 5 different browsers a page that sort of shows which features of HTML5 those browsers support and they don't support. If you haven't been to this website before, let me tell you about it. It's called HTML5test.com. You can type that into your browser. Not only does it do a very, very good job of showing what features that browser supports, it actually assigns a numerical score to each browser, with Chrome leading the way in that numerical score right now. In the demo set that you can download that goes with this talk, I have sort of my own version of HTML5test.com that uses Modernizer and its feature detection API to list a lot of the features of HTML5 and to show you which ones your browser supports and doesn't support. But let's start talking about features. What are the core features that make up HTML5 and why is everyone so interested? One of the big features of HTML5 is a geolocation API. If you want to build location-aware applications, you can do it, and you don't have to have a mobile device to do it. In this case here, when I run this next demo, I'm running on a laptop right now that doesn't have GPS hardware, that doesn't have cellular hardware, but does have a Wi-Fi connection right now. Because of that Wi-Fi connection, we're going to be able to figure out where I am. And in fact, while Wi-Fi positioning data is not always accurate, is not guaranteed to be accurate, my guess is, because a lot of us are carrying certain types of phones here, it's going to be very, very accurate, but we'll find out. By the way, in my slides that introduce features, the green boxes at the bottom show you which versions of all the popular browsers this feature was introduced in. You can see that this one is supported in IE9 as well as most of the others, so it's one of those features that you can use just about anywhere right now as long as your user has an HTML5 browser. So what does the geolocation API look like? By the way, this may be interesting if you were going to build a Bing Scout type application or an Urban Spoon app where you just want to get a one-time fix, know where that user is on the face of the earth so you can recommend restaurants, movie theaters, and things like that nearby. The geolocation API is about as simple as it could be. The getCurrentPosition method is an asynchronous call that goes out and attempts to determine where I am. It can use cell tower triangulation if I have a cell signal. It can use GPS if I'm outdoors where I can see the satellites and the device I'm running on has GPS hardware. Or it can use Wi-Fi positioning if all I have is an IP address. You can see here from the completion function what kind of information you get back when you make this call. At the very least, if the browser can determine where you are, you'll get a latitude and a longitude. If the data is coming from GPS, and only if it's coming from GPS, you'll get an altitude as well. Obviously, we can't infer an altitude from anything other than GPS, from Wi-Fi positioning or cell tower triangulation. With getCurrentPosition, some of these other properties are always going to be null or not a number, heading and speed, for example. But I'm going to show you in just a moment a complementary method named watchCurrentPosition, which instead of giving me a one-time fix, fires a steady stream of callbacks telling me where the user is and where they are as they move around. If you use watchCurrentPosition after the user has moved a bit, heading and speed will take on values. Speed will be a velocity in meters per second, telling you how fast that user is moving, and heading will be a value from 0 to 360, indicating their direction of movement, those values corresponding to points on a compass. By the way, there's nothing in the HTML5 location API that lets you determine where the data is coming from, but there are ways to infer it. For example, if you check the accuracy value passed in, if the data is coming from GPS, you'll typically see a value there between 3 and 7 or maybe 8 or 10 meters, whereas if the data is coming from Wi-Fi positioning or triangulation, it will be much higher, sometimes up to 2,000 or 3,000 meters. Now, quick look at how to handle errors. When you make that asynchronous call to getCurrentPosition, there's no guarantee the browser is going to come back with good data. So, for example, every browser in the world today, for privacy reasons, will, before divulging location data to your code, prompt the user. If the user answers no, there's no way the browser will give you the data you requested. What you will see happen is if you provide a second parameter to getCurrentPosition, as I'm doing here, an error function, you'll see the code permission denied passed in. That tells you the user said no. If for some reason the browser is unable to determine where you are because it doesn't have access to Wi-Fi positioning, cell towers, or to GPS, then you will get position unavailable. Couple of things you should know before I show you a demo. On most mobile devices, a browser will never by default get location data from GPS. Why? Because GPS receivers eat battery power. If you specifically want the data to come from GPS if it's available, you have to tell the location API that, and this is how you do it, by passing a location options object in the third parameter to getCurrentPosition. In that object, you set the enable high accuracy property to true. One other thing that's really useful about this third parameter passed in is the option for timeouts. When you call get current position, remember that's an asynchronous call. You have no guarantee how quickly it's going to return. If you've ever used a Garmin or a TomTom or other device in your car, you know sometimes it might take a minute or two to get a lock on 3 GPS satellites. By default, get current position has no timeout. It will wait as long as necessary. If you don't want it to wait as long as necessary, you can use that position options object in the third parameter to specify a timeout value in milliseconds. Now, if, in this case, 10 seconds after making the call to get current position, it still doesn't know where I am, it will call the error function I registered in the second parameter and pass in the value timeout, so I'll know exactly what happened. One last thing before we look at a demo. Remember, get current position is 1/2 of the location API. It gives you a one-time fix on location. The other half of it is watch current position, which, as I said before, fires a steady stream of callbacks, apprising you of changes in the user's position. Now, in HTML5, there is no API, no property setting, or what have you, to tell the browser what the frequency of these callbacks should be. Most native phone OSs actually let you control that frequency. So you may see wide variations between browsers, but at the end of the day, if you're building an HTML5 app for perhaps a mobile device, or even for a laptop that someone's going to have in their car with them, they want to use it for navigation, you would want to use this method here rather than get current position. And you can also, once you call get watch current position, later on you can shut it off by canceling it as I'm doing here. It's a good idea to do that because remember, if this is a mobile device and it's running on battery power and it's getting the data from GPS, failing to shut this off could drain the battery in that device way too fast. Now let's do a quick demo here. I like to do demos because the truth is, if I don't demonstrate this, for all you know, I could be making up everything I tell you, right? So just to prove I'm not making up what I'm telling you here, let's pop over to Visual Studio for just a moment. I already have up and running the project named HTML5 Demos, whose URL I will give you for download. And we're going to quickly run a little page named maplocation.html. It's in my location folder. You can see I have all of these examples categorized by feature. Now, what I'm doing here is using the geolocation API combined with the Bing Maps control to not only get information about where I am, but to layer that onto a Bing map as well. You can see IE9 prompting me saying, will you allow this application to divulge your location? I will say yes, and I'm just going to click allow once, so the next time I run this demo, it asks me again. Now, right now we're getting the data from Wi-Fi positioning. Tells me I'm in Brussels, and I don't know, that looks like a train station or something. I don't know how close that is to where we are. Now, I'll tell you this. When I was on a different network, when I was up in the speaker room before I came here, but it literally got within 5 or 10 feet of where I was sitting in the speaker room. I was on a different network there. But there's a good lesson here. When the data is coming from Wi-Fi positioning, Microsoft, Google, other companies have all sorts of interesting ways that they compile Wi-Fi positioning data, try to make it as accurate as possible. But there are no guarantees. Sometimes it's very, very accurate. Sometimes it'll actually target the location of your ISP, which may be 50 or 100 miles away. But at least it gets you in the vicinity. Now, I'll leave it to you to look at that sample, look at the code if you want. You'll see it's a very simple page. I'm not doing much more with the API than what I showed you in those slides just a few moments ago. So with that, let's pop back over to PowerPoint and let's look at some more features here. The next feature of HTML5 I'd like to introduce, and I do want to make this one brief, is native support for audio and video. Now, it's interesting, if you walk up to a person on the street today and say, tell me what you know about HTML5, most of them will say, I know that it has native support for video. And that is true. I'm going to give you a 3 to 4 minute primer on HTML audio and video because I want you to see what's wrong with it as well as what's right. You can't fix what's wrong, but you can be prepared for it and make sure that your users don't even know what you had to do to make it work. First off, this is what video in a web page looked like in the old days. We used either Flash or Silverlight generally to play the video. I probably should have used Silverlight here, being an old Silverlight person myself, but since more of the world does stream and play video with Flash today, this is pretty representative of the way we used to do it. In HTML5, video comes down to this. You don't need browser plugins. You use the new video element. I won't take the time to show it, but there is an API around that element allowing you to build your own playback UI with controls, telling the video when to stop, when to start, controlling the volume, and all that sort of thing. But the cool thing is, unlike either Flash or Silverlight, when you use an HTML5 browser to play video, it will provide a playback UI for you. Now, I've taken a couple of screenshots here out of IE and Chrome, and you can see that those playback UIs look similar. The HTML5 video spec, by the way, doesn't tell the browser vendor what that UI has to look like, but it does look reasonably consistent in all the different browsers. Notice how much simpler it is. Just declare a video element, use the source property to point it to a video, and you're ready to go. At least I wish it were that way. Unfortunately, and here's the bad news about HTML5 video, and the same is true of audio as well. The Standards Committee could not agree on a common video or audio format. Remember, this is something that has been designed by committee, and there are a lot of people with a seat at the table: Microsoft, Google, hardware vendors like Nokia, Apple. They all had vested interests in working on this committee. Some companies like Microsoft and Apple, for example, had paid millions of dollars in royalties to license codecs like the ones that are used in MP4. They wanted to see those investments leveraged in HTML5. Other organizations like Opera and Mozilla said, we can't afford millions of dollars for codecs. We need some kind of free codec. We can't support MP4. So the way it shakes out, long story short, there is no one way you can encode an audio or video file and guarantee that it will play back in an HTML5 browser. What you have to do is encode every video or audio file at least 2 different ways to ensure that it'll play. And to do that, once you've done the encoding, to tell the browser you use something called multiple sourcing. Notice here, instead of using a single source element, I'm using child source elements, and I'm telling the browser that renders this content in order, top to bottom, which files I wanted to try to play. What will happen here is if you bring this up in Chrome, Safari, or IE, they'll see that MP4 file, they'll ignore the others, they'll download it and start playing it. Bring this same page up, however, in, say, Firefox or Opera, which don't support MP4, and they will begin working their way down the list. By the way, if you didn't know this already, here's a little tip. When you multiple source a video element like this, you always want to list the MP4 file first. Why? Because of a bug in the iPad OS that causes it to ignore all child source elements except the first. If you intend to support iPad with these videos, always list the MP4 file first. One other thing about video, on the previous slide, I was telling the browser what files it could download to play from, but I wasn't telling it anything about the format of the files. And after all, file name extensions don't mean anything. In fact, on a slide like the previous one, the browser may have to download pieces of each of those files to read the header information, the metadata information, to figure out what codecs and what profiles are used inside it. If I want to be more specific and be conservative with bandwidth, I can use codecs attributes like these to tell the browser specifically what video and audio codec was used. That will prevent the browser from having to download a portion of the file just to figure that out for itself. One last thing before I do a demo. It might be interesting while we're in this transitionary period to HTML5, where not all of your users have HTML5 browsers, to have a fallback so that we could play HTML5 video for them in a browser that supports it, but fall back to something else in a browser that doesn't. Here's a very common technique that devs are using today. What you do is you embed an embed or object element inside the video element, and in that embed or object element, you embed a Flash control or a Silverlight control. What happens is an HTML5 browser sees that video element, knows what it means, knows that that embed or object element has no place inside it, so it just ignores it and plays the HTML5 video. An older browser, however, will skip right over the video element. It doesn't know what it means, but it will see that embed element and say, aha, I don't know what video means, but I know how to create an instance of Flash, so I'll use that to play the video. Again, very, very common technique. Show you a quick demo here, just very, very quick. And then I want to tell you a couple of things about video that you need to know so you don't lose work the first time you try it. Whoops, let's go back and find the right one. Where's VS? There's VS. I'm going to pop over into my video folder, and I'm going to play that video that was playing when you came in. This is an IE9. It's a little, here we go, video of my hobby, which is building and flying big radio-controlled jets. In this case, I've encoded this video twice, once as an MP4, again as an OGG video. I used a free plugin for Firefox called Firefog to do the conversion from MP4 to OGG. If you look inside the page, I have multiple sourced it. In fact, you can see the two source elements there. Interesting experiment to try. Yes, this will play in Firefox and Opera because of the second child source element. On your own, delete or comment out that second source element and see what Opera and Firefox do. You'll basically see a blank rectangle where that video should have been. Something that you should know here, if you download and run these samples that I'm showing you, it's a standard Visual Studio project, but it does not run against the ASP.NET development server like most Visual Studio web projects do. The reason is this. Most browsers, not all, most browsers will completely ignore the video that they download and won't even play you the first frame of it unless your web server is configured to serve up the proper content type headers in the browser's requests for the video. The content type headers come back in the response. IE, for example, won't play the first frame when it requests that MP4 file unless the response that comes back has content type video/MP4. In the ASP.NET development server, you can't control content type headers. What I'm doing here is running against IIS Express. So in order to run my samples, you need to be running against IIS or IIS Express. If you look over in my application host.config file, you'll see that I've added mappings for file formats and codecs that aren't, or MIME types that aren't there by default, like this OGG video with the file name extension OGV. But remember, when you're doing HTML5 video, if the file is downloading but the browser's playing nothing, 90% of the time it's because you don't have the MIME type mapped to the file name extension on the server. Something to go look at. All right, let's get back and get on to some more interesting things here. What about Canvas? Next to audio and video, the Canvas API is probably the most well-known and most recognized feature of HTML5. And it is significant because since the dawn of time, if we wanted to draw directly into a browser window, we needed a browser plugin like Silverlight or Flash to help us do that. Now from JavaScript, we can draw directly into the browser window using the Canvas API. It is one of the most significant parts of HTML5. I want to give you a quick tour of the HTML5 Canvas API, show you kind of how it works, how it's glued together, show you some examples. I will warn you this. It's a fairly primitive, immediate mode graphics API. If you've been doing SVG and XAML and things like that for the last 10 years, or OpenGL or DirectX or Direct3D, it's going to feel incredibly primitive. But if you can get past that, again, at least we finally have the ability to draw directly into that browser window. Now, see what it looks like, just really quick. To draw something to a browser window using the Canvas API, you start by declaring one or more Canvas elements in your page. I've got examples that declare up to 15 of them, I believe, although one is probably more common. That Canvas element represents a drawing surface. You can even dimension it with width and height attributes. Before you can draw anything to it, though, you have to have something called a rendering context. And you get that rendering context by getting a reference to the Canvas element itself and calling its getContext method, as I'm doing right here. It's actually the rendering context, not the canvas, that has the API that lets you draw to the browser window. That API consists of a couple of dozen methods, couple of dozen properties. Show you some quick examples here, and then we'll look at some real live applications that use this. By the way, great example of the Canvas API at use out in the wild today, www.worldsbiggestpacman.com. Not only does it faithfully replicate the old Pac-Man video game, but it lets you build your own levels and submit them. There are, I think, a couple 100,000 levels available now, more than you can ever play, I think. Then again, I don't know. My kids like video games. They could probably get through all 200,000 levels given a little bit of time, maybe a long weekend or something like that. Anyway, that application uses the Canvas API to draw the Pac-Man grid, to move the characters around and things like that. But we're going to start simple. Here's what this API looks like. Suppose I want to draw a rectangle. I get a reference to my canvas, call getContext to get a rendering context. And through the rendering context, I call strokeRect, which draws the rectangle outline that you see here. This API is pixel-based. What I'm doing with this call to strokeRect is saying I want the upper left corner of that rectangle to be at 100,50. That's pixels right of and down from the upper left corner of the canvas. Parameters 3 and 4 are the width and the height of that rectangle in pixels. If I wanted to do something really sophisticated, like change the color of that outline, I would do it by changing the stroke style property of the rendering context. So you see the pattern here? The rendering context gives us methods like strokeRect, fillRect, and a bunch of others to draw things. It also gives us a bunch of properties with names like stroke style and fill style, which let us control the visual attributes of what we draw. So another example, if I wanted to thicken up that line, I could use the line width property of the rendering context to do that. If I wanted to make that a filled rectangle rather than an outlined rectangle, I could replace the call to strokeRect with a call to fillRect. And if I wanted to change the fill color to something other than black, I could do this. I could use the fill style property, to which I can assign a valid CSS color identifier, in this case the string red. And I could even do gradient fills. It's not like XAML where you declare a linear gradient brush. Instead, you create a linear gradient object and assign it to the fill style property of the rectangle. The good news is it's not just rectangles. You can do this with text, with paths, with virtually anything that you can draw with the Canvas API. You can even fill with patterns, which is kind of interesting. I'm going to use this in a demo in a moment. Assuming I show that one, I've got tons of Canvas demos. I think I'll probably show this one. One of the things that this does is it lets you draw images or portions of images onto a canvas. It also lets you transfer pixels from one canvas to another, which is useful in some advanced scenarios where you're doing double buffering. Another thing it allows you to do is grab frames from a running video to capture thumbnails. You can pass into that first parameter there to create pattern. Not a reference to an image, not a reference to another canvas, but a reference to a video element playing a running video. And believe it or not, you will get a frame from that running video. Let me show you a quick example or two here involving Canvas, and I'm going to say a little bit more about Canvas and show you more demos. So I'm going to pop up here to my Canvas folder. And I'm going to start with this one right here, a little page named chart.html. One application for the Canvas API is to draw boring graphs and charts and things like that. That's exactly what I'm doing here. Now, I haven't gone up to the server to download an image. I'm using calls to fillRect, just like you saw in the slides. I'm also using methods named moveTo and lineTo to define paths that are nothing more than lines to draw the bars you see in here. There are also methods named strokeText and fillText in that rendering context that let you draw text onto a canvas. You can even rotate the text here. In fact, it's not just text you can rotate anything. Because in the Canvas API, there is support for rotate transforms, translate transforms, scale transforms, and custom transforms. In this example here, to produce that vertical text you see on the left axis of this chart, I called the rotate method that the rendering context gave me to apply a rotate transform to rotate the entire coordinate system 90 degrees before I drew that piece of text. So it's a simple example, but it's just one of the many kinds of things that you can do with this Canvas API. Let me show you another one real quick. Here's kind of an interesting one. Some of you may be I won't say old enough. Maybe you've been around long enough to remember the old Scribble tutorials from Visual C++ many, many years ago. Here it is in HTML5. What I can do is use my mouse, or if I run a touch device, my finger to draw things like this. All I'm doing here, by the way, in JavaScript is taking the mouse move events that report where the cursor is moving. And every time I get that mouse move event, I use a path to connect the current mouse position to the previous mouse position. I'm just calling those methods named move_to and line_to under the hood. Then I call stroke to actually apply ink to the path. Not much different from what you saw with the rectangles a few moments ago. Another thing that could be kind of interesting, I'll just show this real quickly. Here we see an example of a page that has multiple canvases. In fact, if you look at the DOM here in this page, take a look at this. Whoops, that's the wrong one. I want puzzleanimation.html. How's that for a stack of canvases? Here's what I'm doing in this example. I'm taking an image and I'm programmatically using the Canvas API, cutting it up into a bunch of little 150 by 150 pixel squares. Each of those squares is a canvas. And then I'm using jQuery to sense clicks of those canvases and jQuery to animate the movement of the pieces when you click one of the pieces next to the adjacent square. So, could I do that kind of thing without HTML5? Sure, if I had Flash or Silverlight, it's kind of neat that I can do this in the browser without the aid of a browser plugin. But there's much, much, much more I could say, and in fact will say, about that Canvas API. So let me show you this. One of my favorite parts of the Canvas API is that it allows you to manipulate pixels directly. You can create images from scratch. You can grab images from a source, perhaps from the local file system. Get access to the individual pixels, so you could build Photoshop type applications if you wanted with HTML5 and its Canvas API. In fact, I'm going to show you a couple of examples to demonstrate that, but first let me show you the mechanics real quickly of dealing with pixels using the HTML5 Canvas API. In this example, I'm generating an image from scratch. The key is the call to create image data on the rendering context. That creates an image data object, which is basically an array-like object that contains all the pixels in the image. I can walk through all the pixels, beginning with the one in the upper left corner, in row first order by iterating over all the items in that image data object. In fact, there will be one element in it for each of the pixels inside. All I'm doing here is generating this sort of fuzzy television image by assigning each pixel a random color. But something else you can do is take an existing image, get access to its individual pixels, and modify them. The key is that instead of calling create image data to create a brand new from scratch image data object which you can fill with pixels, instead you call get image data so that the rendering context returns to you an image data object pre-populated with the pixels of the image. Now you can look at those pixels one by one. You can change them if you want. Then when you call put image data, you write those pixels back out to the canvas. Let me show you a couple of quick examples here. I think you'll like these. First one I'm going to show you, and by the way, with this one we're going to learn an interesting little lesson about HTML5 and Canvas. This one is called Mandelbrot.html. The entire UI of this page is nothing more than one image, and every pixel in that image is being generated each time the app starts up and each time I click somewhere. You probably recognize that as the most famous fractal in the world, the Mandelbrot set. Now, I'm going to click there. I'm generating a new image, pixel by pixel right now. In a moment, you're going to see it come up. In a moment, you're going to see it come up. I have to work on my timing. In a moment, you're going to see the zoomed in image. I don't know about you, but I don't care much for that performance. There is a fix for it. If you work for Microsoft and want to get fired, just do what I'm about to do. There is this other browser vendor out there. Now, before I get in big trouble, let me tell you a little bit about what's going on here, okay? If you're a browser vendor and you want to build benchmarks that show that your browser is the fastest in the world, you can do it. There are things that IE9 can do an order of magnitude faster than any other browser out there. But this is not one of them. Here's what's going on. You may be tempted to see how slow that image generation is in IE9 and say, well, that's JavaScript for you. But it's not. Did you know JavaScript is no longer an interpreted language? Almost all browsers today JIT compile JavaScript almost the same way we JIT compile C#. JavaScript can be faster than C# in some cases these days. But here's the problem. JavaScript is a typeless language. If you're the one writing that JITting engine, you have to make certain assumptions about what to JIT and how to JIT it. It just so happens that in this example, all this math I'm doing here, generating 1 million or so new pixels each time the user clicks, is heavily floating point. But IE optimizes its JITting engine for integer math. Now they're changing that a bit in IE10 because, no one on the IE team likes this right here. It makes them look sort of bad. It just so happens that Chrome and Firefox and a couple of others do a different type of optimization so they can be very, very fast in doing this kind of math. But the main reason I wanted to show you this is, number one, here's an example of kind of a cool application that uses the Canvas API to generate new images. And number two, just because the API works in all these browsers doesn't mean it's going to be equally fast. You have to test. This isn't going to be the only case where you see wide differences in performance between the different browsers. Now, lest I get in trouble here, let me show you something else. Here's one of my favorite demos, which uses not only the Canvas API, but the File API as well, which allows you to read files in JavaScript. Now, this one, it turns out in IE9 it can't run because while IE9 does support the Canvas API, it doesn't support the File API, but no problem because IE10 already does support it. Let's close that down and just bring that same page up in IE10. Now, let's see here. Let's get that URL in there. By the way, if you're in tomorrow's Take a Ride on the Metro talk, I'm going to show you the same application. I've got it written both in HTML5 and JavaScript and XAML and C# for Windows Metro. I'll be running it on my nice little touch tablet where I can do pinch zooms and all that kind of stuff. It was actually interesting. If you're writing Metro applications, it is much, much less work to port them from HTML5, believe it or not, than it is to port them from Silverlight. Now watch this. I'm going to go load an image from the file system here. In fact, the one I'm going to bring up is this old picture of my daughter. Now, she would die if she knew I was showing you this right now. See those red eyes? She's a freshman in college now, so, but watch this. I'm going to click those red eyes. Tomorrow it'll be more impressive on a touchscreen when I just touch the red eyes, and I fix those red eyes. Let me tell you what's going on here. Here's a great example of the Canvas API at work. I'm using an input type equals file element, standard HTML, to provide the little UI for selecting a file. Once the user selected a file, I'm using the HTML5 file API to open the file and read it. I then take those image bits, display them to the user on a canvas, and call getImageData so that I have an image data object exposing to me all the pixels. When the user clicks or touches one of those red eyes, I then figure out where in the image the click occurred, what pixel was clicked, and I run a red eye reduction algorithm on that pixel and the pixels in an area around it. Then at the end, I take that image data object that I've modified, call putImageData to blow it back out, and lo and behold, you can now build a type of application that we were never able to do before in HTML5. Question here? You cannot have a date with my daughter. Oh, that wasn't the question? Okay, I'm sorry.
What happens when you click on another red item in the picture?
Yeah, so what happens when you click on other red items in the picture? Boy, I'll bet you're one of the kids who took his toys apart when he was a kid, right? So, yeah, it does change those other... I don't really know if it's eyes or not. So when I click on other red stuff, you see the red eye reduction algorithm at work there. The moral of the story is, don't click anywhere other than an eye. Right? I'm sorry, I'm just being facetious there. And by the way, you seem like a nice young man. If you do want to date with my daughter, just see me afterwards. And I'm hoping and praying my daughter never hears that I just said that. She will kill me. It would be even worse if I asked for money, yeah. Yes, it would. Since I'm getting into dangerous territory, we're going to change the subject just a bit here. One of the the coolest features of HTML5 is something called web workers. Now, let me ask you this. Did you ever believe that you would see the day when you could do multi-threading in JavaScript? Boy, if you'd have told me this 5 years ago, if you'd have told me 2 years ago, I would have said, you are nuts. I mean, this just sounds like a train wreck looking for a place to happen, right? Well, sure enough, we can do multi-threading in JavaScript now. We don't call them threads, we call them workers. Now, here's what's important about this. Number one, you don't have to be a threading guru to use workers. Let me ask you this. If you've written multi-threaded code, concurrent code before, is it hard to launch a thread in Windows? No. My wife could do it. See, I'm going to get in trouble with every female in my family. It's easy to create threads. What's hard is synchronizing those threads so that they work together, right? That's where all the bugs come in. Well, guess what? In JavaScript, we now give you an API for launching threads. Technically, you're not launching threads. You're scheduling a JavaScript code to execute on a background thread coming from the operating system thread pool without a synchronization API. It vastly simplifies threading. Now, you're thinking, but Jeff, with no synchronization API, every app that uses workers is going to crash, right? Well, hopefully not. There is one very crude synchronization mechanism, which is, you'll see in my next example, you post message from a background thread back to a UI thread. By the way, a background thread is very limited in what it can do. It cannot touch the UI. It runs in a very special context where there is no document object, there is no window object. You can't do a document.getElementById on a background thread to try to touch the UI because there is no document object. It's undefined. Within those constraints, this is very powerful. And here's what I like about it. Almost all of us are running multi-core processors these days. I'm running on a laptop with an i7 quad-core chipset. The only way that in an HTML5 app, if I'm going to use it to build real apps, only way I can leverage those cores is to write a multi-threaded application. Now, there is no HTML5 API, unfortunately, for determining how many processors or how many cores are on the host device. But since under the hood, the browsers are using the host operating system's thread pooling API, it doesn't really matter. You can create workers, since they don't correspond one-to-one to threads, to physical threads. The OS decides how many real threads should be there, typically based on things like the number of cores. Then you're insulated from it. Let me show you really, really quickly here what the API looks like, and then we will take a look at an example or two. So there are actually two types of workers, dedicated workers and shared workers. There is pretty good browser support today for dedicated workers, almost none yet for shared workers. Wait a year or two, all the browsers will support shared workers. Dedicated workers are called that because once they're created, they have a connection to the thread that created them so that they can post message back and forth with that thread. But a dedicated worker doesn't have the ability to branch out and communicate with other threads. So if I want to create a dedicated worker, here's what I do. I new up a worker object and pass in the URL of the JavaScript file that's going to execute on that background thread. It's just like a script tag in HTML. The difference is the contents of that JavaScript file are now going to execute on a background thread. And if that were into the story, it wouldn't be very useful. Since you are limited in what a worker can do, you can't touch the UI. It's really designed for doing background computational tasks. What if you do some computation in the background, but you want to show the results to the user? Very reasonable thing to expect. Well, here's what you do. In your worker, once you arrive at the result, you call the HTML5 post message API to post back to the thread that created this worker. You can pass basically anything in there. Browsers are literally evolving week by week as new features are added to the web worker specification, making the transfer of large objects very efficient. You're going to see an example in a moment where I'm passing very large objects from thread to thread. Of course, if that worker is going to post a message back to the UI thread to do a UI update, UI thread will want to receive those messages. So what we do in the UI thread is, after newing up the worker, we register a handler for the message events fired by the worker. And by the way, this mechanism that allows the worker to post messages to its owner, the UI thread, and the UI thread to receive those messages, can work the other way as well. You may want to be able to post messages to your worker, maybe giving it some startup parameters, for example, or sending it a command to go do some more work for you. So you can call post message on that worker object you created, and in the worker, if you want to receive those messages, you can create or register an event listener for message events there as well. So we have a two-way communications mechanism between the two. Last thing I want to mention before we look at an example is this. What's going to happen if something goes wrong in that worker? What do you think is going to happen if an unhandled exception occurs? Nothing good, I can tell you that. Here's what you should do. When you create a worker, always, always, always register a handler for error events. Because if a worker does suffer an unhandled exception, the browser posts an error message to the UI thread. This is your only opportunity to know that something went wrong in that background thread, and perhaps to alert the user to that. Did I see a hand? Yes, sir. Can you simulate in browsers that don't support it? They could be simulated using timers, but in a browser that doesn't support it, short of a plugin, you can't simulate it with real threads. Now, let's look at an example here. So I want to go back to Visual Studio here. Wow, is it 3:30 already? The time is getting away. That's okay. Let me go down to my workers folder. And I've got a little page here named Multi-Mandelbrot. Now let me tell you what I'm going to do real quick. Given that it was taking IE a long time to render that fractal image a moment ago, I thought, wouldn't it be nice if we could leverage the fact that I'm running on a quad-core machine, divide the display into quarters, and let each core in my processor's chipset render 1/4 of the screen and have them do it all in parallel. That's exactly what I'm doing here. My UI thread is doing a little more now than creating 4 workers, which will create up to 4 real threads on a quad-core chipset. Those workers are now responsible for doing all the pixel computations for the 1/4 of the screen they own, but then they can't take the image data objects that they've created and actually blow them out to a canvas. So what do? They post message back to the UI thread. The UI thread gets those one at a time. It can't get them all 4 at the same time because one thread can only do one thing at a time. And the UI thread renders those pixels. Consequently, you'll see here, if you look very closely, you'll see the display being painted in fourths. Let's see here. Let's run this thing in IE9, which doesn't support workers, so we'll go run it in a browser that does. IE10 has very good worker support, so does Chrome. Let's just run it in Chrome since that's really handy here. And it was fast. You have to be very fast, but if I click, well, it's a little hard to see there. You could see it there if you were really, really fast. In theory, I'm getting better performance here. Multi-threading usually doesn't mean you perform better, right? But when multi-threading allows you to do 2 or more things concurrently on different cores, then it can give you better performance. We're actually rendering this image quite a bit faster each time now because we are leveraging these multiple cores. Pretty cool stuff, will you agree? Very, very cool. Now, what else do we have in HTML5 that's noteworthy? How about web storage? So it's very reasonable to expect, if you're going to use HTML5 or any other platform to build browser-based apps, that you might need to store stuff locally on that host device, on the host file system or something. In the past, we've used cookies and things like that, but there are lots of reasons we don't like to use cookies. They travel up to the server in every request, meaning they pollute those requests. They reduce effective bandwidth. Cookies are limited in the amount of data they can hold, typically 4K. Cookies are also, if passed over HTTP, not very secure, right? Because they're passed in plain text. Wouldn't it be nice if HTML5 had a solution for storing data on the client side that didn't cause it to be passed up and down in cookies? Well, it does. There's a specification called the Web Storage Specification, which defines 2 types of client-side storage: local storage and session storage. Session storage is not very interesting because that what you write to session storage is not persisted. When the browser session ends, the data goes away. What is interesting is local storage. You can write data into local storage, and it's basically persisted by the browser in the local file system. On mobile devices, it's persisted in flash memory. Bottom line, the data outlives the browser session. So I can store that data, whether it's something simple like a user preference or something that's much more complex, go away for a year and come back, and most likely that data will still be there, just as if you had created a file on the local hard disk, you went away for a year, you come back, unless someone's deleted it, that file is still there. Now, web storage or local storage is very simple. There are mechanisms in HTML5 which aren't really widely supported yet, but will be soon, that let you store structured data. You don't use local storage typically to store structured data. All you can store there are name-value pairs. Quick example here, if I want to write something to local storage, I can use the set item command on the window.localStorage object, as you see here. Later I can call get item to read it back. If what I'm trying to read was not in local storage, I'll get back no. By the way, there are some irritating differences between browsers here. The spec says that if you attempt to read something from local storage that isn't there, you're supposed to get back null. IE9 passes back empty strings instead. You have to be aware of that because if you're doing a test for not null like I'm doing here, that code will probably break on IE9. And that's not to pick on IE9. All browsers have little quirks, places where they don't conform to spec. We're all human after all. Here's something else to know about local storage. What you write to local storage is actually serialized into a string and stored there as a string. There are two implications. Number one, in some browsers like Firefox, they actually store Unicode strings, which means the volume of the data that they store in those browsers is twice what it is in browsers like Chrome and IE. Do we really care? Yeah, because per the web storage recommendation, most browsers limit you to 5 megabytes of local storage. That is not a per app quota, that is a per origin quota. So it's kind of like isolated storage in Silverlight, in that all the Silverlight apps that live in the same origin domain, like www.microsoft.com, share a quota on the client side. Same with HTML5. You have to be prepared that when you try to write something to local storage, it may fail because someone else in your organization has already used up your 5 megabyte quota. Unlike Silverlight, HTML5 gives you no API for determining what that quota is or how much of it remains, or even for requesting a quota increase, although some browser vendors have added extensions, browser-specific extensions, that do alleviate some of those limits. But the other thing to know, the other reason it's important to know that what you write to local storage is serialized into a string is when you read it back, it's always a string. If it was an integer you wrote into local storage, you read it back, you want to treat it as an integer, you have to parse it. Here I'm using parseInt to do that. Here I'm writing a 2-element integer array into local storage and having to do some work when I read it back to parse it back out from the string. Easy thing to do, by the way, just JSON stringify everything you put in local storage. You could even store complex objects that way and then pass it to JSON.parse when you read it back out. By the way, in case you didn't know this, every HTML5 browser in the world today does build in methods named JSON.stringify and JSON.parse to make it easy to deal with JSON data. Let me show you a quick example here. Back to Visual Studio, and I'm going to go into my storage folder. I'm going to run something called Storage Scribble. This is another take on that Scribble application I showed you earlier. Obviously something's up because when it came up there's already something there, but all it's doing is this. Each time I draw something, I'm writing the coordinates of a line, a pair of X and Y coordinates, into local storage. Now, each time the application starts up, I can reach into local storage, see if there were some lines recorded there. If they are, I'll recreate them when the app starts up. To prove it, let me do the Control F5 thing again. There we are. Because this is local storage, not only does it not matter if I close the browser, I could shut my machine down, go to Hawaii for a couple of weeks, have a nice relaxing vacation, come back, start this application up. I'm going to see the same thing then that I see right here. That, in a nutshell, is local storage. Client-side storage, by the way, there's no security. Most browsers give, each browser, I should mention this, the HTML5 specification tells a browser vendor what the local storage API has to look like. It does not tell the browser vendor how the data is to be stored. Every browser stores it in a different place. Therefore, what IE writes into local storage cannot be read by Chrome and vice versa. Also, most browsers do allow the user to see what's in local storage. If you write a username and password in there, a user can see what's there, so never assume that it's secure. If you have to write something in a local storage, it has to be secured. If it needs to be encrypted, it's your job to do that. There's no option in HTML5 for having it do it for you. Now that caveat, I think you'll find that local storage will serve you well. What else can we get into? How about the file API? Yes, sir. Can you remove other data? So can your application remove data written to local storage by other apps? Yes, if they share an origin. So origin in HTML5 is defined as a combination of host, protocol, and port. All apps that are hosted, say at let's say http://www.microsoft.com, all through port 80, all of them share an origin. Two apps who share that origin can see what each other has written into local storage. They can overwrite it. They can delete it. They can call clear on the local storage object and blow away all local storage from the origin. Is there anything you can do about that? Absolutely nothing. It's not like Silverlight, where it's scoped per domain, or Silverlight for Windows Phone, where every application has a unique ID, and what that application writes to flash memory on the Windows Phone is scoped by that ID. In HTML5, everything in an origin shares a quota, shares the same store in local storage, and there's no way to prevent one from overriding another. Conversely, if two applications do not share an origin, there is no mechanism in HTML5 for them to share data through storage. Real quickly here, because we're almost out of time. File API. If we're going to use HTML5 as a platform, we need to be able to read files. It's interesting. There are three different file-related specifications in HTML5. The first one, and the most mature one, is the file API specification. When you look inside, what it gives you is an object called a file reader that lets you open a file and read its contents. Later on, somebody looked up and said, you know what? We need an API for writing files as well. It was too late to go back and call this one the File Reader API, so it's still called the File API, but today there's a separate File Writer API, which few browsers implement yet, which will ultimately allow us to write to the file system. In other words, today, while I can use the canvas to edit an image that the user's loaded, and I can use the file reader object from the file API to read the data. Once I've fixed my daughter's red eyes, there's no way in HTML5 for me to store that modified image back. That will change, but it hasn't changed just yet. Let me show you really quickly here, because we're almost out of time. In fact, we have about 3 minutes, so I'm just going to go to a couple of demos here. By the way, let me show you this. In terms of the slides, I promised you that I'd give you a URL for downloading all these examples. You can go to this URL at your convenience, and you can download the zip file containing all of these samples I'm showing here and a whole lot more. winelink.com/downloads/html5.zip. So that photo finish application I showed you earlier, where I fixed my daughter's red eyes, again, it uses not only the Canvas API, but the file API to read the file contents. If you want to see how that works, take a look inside photofinish.html. I've also got some other interesting examples in here. I unfortunately did not have time to cover networking, but let me tell you this. There's some awesome things coming in networking in HTML5. For example, here's something called XHR2 demo, which is not supported in IE9. But we'll just go try another browser. Again, I'll bring Chrome up because I know it supports this. This is a demonstration of XML HTTP request level 2. What is that? What's the most frustrating thing about AJAX or XML HTTP requests today? It's that you cannot in JavaScript go cross-domain or cross-origin with a silly little AJAX call, right? They're finally fixing that. One of the members of the family of HTML5 specifications is one for XML HTTP request level 2, which not only adds interesting new things to AJAX, but also gives you the ability to make cross-domain, technically cross-origin calls with AJAX. Now, I won't go into the details, but in order for those cross-origin calls to take place, both the browser and the web server have to support a protocol named CORS, Cross-Origin Resource Sharing. There aren't a lot of public servers out there today that support it, so I've wired up my home server back in the US to support CORS, and now that I'm running in a browser that supports CORS, here's what I've done. I have built and deployed a WCF service whose source code is part of this project if you want to see it, deployed it on a server back in the southeastern United States. This service has a method that lets me input a U.S. postal code, and it returns to me information about the current weather at that postal code, as well as the city and state that it corresponds to. What's significant about this is that I'm using XML HTTP request level 2 to call directly cross-origin from this browser running on this machine to this service, which is hosted in a completely different origin. Not possible without turning off security in the browser with AJAX level 1, with AJAX level 2. I live in a little town in zip code 37934. Let's see if it's sunny and balmy back there today. We're going out on the network. Sort of expected it to come back by now. It's cold back there. That's Fahrenheit, by the way, not C. So it's 37 degrees Fahrenheit where I live there. Again, XML HTTP request level 2 lets you go cross-domain. If you attended Scott Guthrie's talk on MVC4 today, he probably mentioned WebSocket support coming in MVC4. WebSockets are one of the most important and talked about features of HTML5. What they allow you to do is to open a duplex TCP connection between a browser and a web server using a simple HTTP handshake. Long story short, if you've ever had the need to push data down from that web server rather than just pull it down from the client, WebSockets are one of two solutions that HTML5 gives you for doing that. I wish I had more time, but I do not. Remember, you can go download all of these samples here. Hope it's been a good hour and 15 minutes for you. Thank you so much.